So the first question, as you can say, is if A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3 is a non-singular matrix, then show that A is invertible and A inverse equal to 1 upon determinant of A into adjoint of A. If you see in the if you see, it's mentioned that adjoint of A upon DETA, so we can write that as determinant of A as well. So there's nothing wrong with that, so we can quickly move towards with this question. So now what we can understand is it's a non-singular matrix. Since it's a non-singular matrix, we know that determinant of A, which we can write as determinant of A is non-zero. Okay, since it's a non-singular matrix, so determinant of A is non-zero implies inverse exists. Therefore, what we can say is, therefore, A is invertible. Invertible means its inverse exists. Now, very quickly we'll find out its inverse. Now, let us suppose that for the given matrix, like A, A1, B1, C1, A2, B2, C3, A3, B3, C3, its cofactor, let's say for A1, the cofactor of A1, basically you can write as, let's say, we'll write this as capital A1. Similarly, cofactor of A2 is capital A2 and so on. Okay, so we can write basically that AI, BI, CI are the cofactors of AI, BI, CI. Okay, where I ranges from 1 to 3. Okay, like A1 is A1 and so on, right? We can understand that. So its cofactored matrix would be, so when we write cofactored matrix would be capital A1, B1, C1 and so on. Now we know that what is actually adjoint of A. So adjoint of A formula is clear with everyone, I guess. So adjoint of A, okay, adjoint of A, if we define, that is nothing but, right, it's the, we'll write first the cofactors A1, B1, C1, then A2, B2, C2, then we have A3, B3, C3, and its transpose is what we call as adjoint of A. Okay, now very quickly we'll find out, next step would be we'll find out the product. The product is A into adjoint of A. A into adjoint of A or adjoint of A into A. It's one and the same thing. Okay, let's first find out adjoint of A into A. We'll get to know why we are finding that. Adjoint of A into A. Adjoint of A is like A1, B1, C1, A2, B2, C2, then A3, B3, C3. It's transposed into A. A is nothing but A1, B1, C1, A2, B2, C2. Then we have A3, B3, C3. Correct? Now, so very quickly we'll find the product. So I'm finding its product here. So this is equal to, first we'll write this like transpose. Transpose means we'll write the first row as first column, second row as second column, third row as third column. So this will switch to A1, B1, C1. First row will become first column. Horizontal is what we call as row. Vertical is what we call as column. Okay. Similarly, we'll write A2, B2, C2, A3, B3, C3 multiplied by A1, B1, C1. Then A2, B2, C2. Then A3, B3, C3. Now, very quickly we'll multiply both of them. Now, let's understand the first. So how to generally multiply? I'll just give you a brief idea. See, whenever you are multiplying, its order is 3 cross 3, its order is 3 cross 3. So the number of basically, so first is what we call as number of rows, second is what we call as number of column. Number of column of the first, first matrix should be equal to number of rows of the second matrix, right? So both are equal, final product would be 3 cross 3. So basically what we'll do is, first element is, let's say A11. A11 means we'll take the first row and the first column. First row of the first matrix, first column of the second matrix, right? So this is going to be A1 into A1 plus B1, plus we'll write A2 into A2 plus A3 into A3. Correct? Similarly, we'll have A1, A2 plus B1, B2 and so on. So the second element is going to be A1, B1, first row, second column, A1, B1, A2, B2, A3, B3 And similarly, because of the space, we can adjust it that, right? Similarly, you can write A1, A2, B3, A1, A2, A3, and C1, C2, C3, right? A1, C1, A2, C2, and A3, C3. Similarly, let's write this one. It's B1, A1, B2, A2, B3, A3. So write the first one B1, A1, B2, B2, sorry, B1, sorry, A2, my bad. A2 plus B3 and A3. Similarly, the second one is B1, B1, B2, B2, B3, B3. Okay. B1, B1, B2, B2, B3, B3. Similarly, the third one will be B1, C1 and so on. B1, C1 and so on. Okay. Now we can write that. Similarly, the third one would be C1, A1 plus C2, A2, C3, A3. Similarly, it's going to be C1, B1, C2, B2, C3, B3. Okay. Now the last one is important. C1, C1 plus C2, C2, C3 plus C3, C3. Now the main idea is, right, so we know that what is actually determinant of A. Determinant of A is nothing but when we take, let's say, we define its determinant value, right? So we know that it's first A1 into multiplied by B2, C3, B3, C2 with sign. That is nothing but a cofactor. Sorry, that's nothing but when we talk about cofactor and when we just multiply with the negative sign. So basically this is a minor. When you multiply with the sign plus or minus, we'll get a cofactor. So our main idea is if you take any element and then multiply it with its cofactor, then if you add the other element of basically the same row or the same column and multiply with its cofactor and so on, it's always is determinant of A. So if you take first, like if you take the sum of product of like element of the first row and its like its cofactor, it's always equal to determinant of A. So you can write sorry, A3 into capital A3 plus B3 into capital B3 and so on, right? Or you can go with the column as well, like A1 into capital A1 plus A2 into capital A2, A3 into capital B3. This all is going to be determinant of A. So this is going to be determinant of A. You can write that as determinant of A. This is determinant of A. This is determinant of A. This is the first property. The second property is that whenever you take, let's say, the first element, like element of the first column, and now if you're multiplying with the cofactors of any other column. Now very important, this is like for us to understand. If you take sorry, if you take the elements of the first column and when you multiply, like when you like add with the sum, like the sum of the product of the elements and with the cofactors of any other column. If you're taking the column, then it should be column. It's always 0. Like A1 into capital B1, A2 into capital B2, A3 into capital B3. It's like plus it's gonna be 0. Okay. Same goes with the row A1, B1, C1, capital A2, B2, C2, capital A3, B3, C3. The sum would be 0. So this sum would be like A1, A2, A3 are the cofactors of the first column. B1, B2, B3 are the elements of the second column. So its sum of the product would be 0. This is 0, 0, 0, 0, 0, 0. So you can take determinant of A common. This would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Very important for us to understand, we can only take like in basically matrix, we can take only common from if that number or any element is common in all the elements. This can be written as 0 into determinant of A. Okay. Sorry, so determinant of A we can take common. So this is going to be determinant of A into I. So first thing is, I guess clear with everyone, adjoint of A is equal to determinant of A into I. So I very quickly will wrap this and we'll move towards the just conclude with this answer. So meanwhile, what I will just quickly explain this once again. So determinant of A is like since it's non-singular means determinant of A is not 0. Since determinant of A is not 0, so we'll say that it inverse exists, means it is invertible. Okay. So now cofactor of A1 is capital A1. Similarly, AI, BI, CI are the cofactor of small a, small b, small c, where I is 1, 2, 3. Now adjoint of A is the transpose of cofactor of A. Now adjoint of A into A, transpose means first row will become first column. This is the first element, first matrix. This is the second matrix. Now we'll multiply A1, A2, 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 A3, A3. First element A1, B1, A2, B2, A3, B3. Second element, and similarly the third element. Now this is always 1, and when you take like with the other columns or other rows, it will become 0. Okay, so 0, 0, 0. We can take determinant of a common. This will become 1, 0, 0, 0, 1, 0, 0, 0, 1, which is determinant of a into I. So I guess till here it's clear with everyone. Very quickly I will wrap this and explain the next part. La, 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 la. In case you have any such doubt, let me know. Okay everyone, so let's very quickly focus. What we have got till now is adjoint of A into A is equal to determinant of A into I. Now what you can do is you can always use the similarly, one of the best thing. Okay? Similarly you can write A into adjoint of A is determinant of A into I. So what we can write from this is adjoint of A into A is A into adjoint of A is equal to determinant of A into I, correct? Now we know that, what we know is that if for any two matrix A into B is B into A is equal to I. Okay, and if A is non-singular matrix, then what we can write, B is nothing but A inverse for all values of like A, right? So if AB equal to B equal to I, okay, then what we can say is directly it's nothing but B is A inverse. Okay, like the same logic, what we can write here is adjoint of A into A, and we'll like divide by determinant of A. Determinant of A is a number, okay, like 5, 3, 2, 8. So we can divide it by determinant of A. This A into adjoint of A into determinant of A is I. Now if we compare this, what we can say is this part, like no need to circle this for understanding purpose we are doing this. So it's B into A into B is equal to I. So what we can from this compare is like this is nothing but A inverse. So A inverse is adjoint of A into determinant of A. Hence proved. Okay, so we are understood with this question, right? Quickly, we'll first write cofactors of A and then multiply both of them, A into adjoint of A. We'll get determinant of A into I. Two important properties: sum of product of like elements of the first row or first column with their respective cofactors. It's going to be 1, and when we take another row or column, obviously column or row, then it's going to be some product of sum would be 0, right? So you use this, and yeah, AB equal to BA equal to I, you have to mention this. So yeah, in this way you can able to understand this question and able to score this question. Some important points for writing in particularly boards examination is make sure you're writing all the steps very neatly. First thing. Second thing, if some important formulas are there, mention that, circle that, like AB equal to B equal to I, B equal to A inverse, you can mention this as well. And then write finally A inverse is equal to adjoint of A equal to determinant of A, and hence prove. Yeah, so in this way we'll proceed. So thank you so much everyone, hope you understood. Quickly I will move towards the next question. We'll meet you in the next video. Thank you so much. I'm a mathematics professor, Lalit Rankawat, signing off. Take care of yourself. Bye everyone.